Good afternoon, everybody. So we are going to continue the unit number 4, which we have been started in the previous classes. So today we are going to see the next bit of unit number 4, that is tolerances. In earlier case, we have just started that unit number 4, and we have seen the basics of part design. The name of this chapter is design of plastic parts. So outcome of this chapter is, at the end of this chapter, student will be able to design some given simple plastic component. Now, for reaching you up to that level, some important concepts must be cleared. So for clearing that concept, we are here covering the number of points. So in the previous class, what we have covered? In previous class, we have seen the different aspects of part design. Start with general design, then second one is design of this assembly, then mold design. Sorry, second one is structural design. First one is general design, second is structural design, third one is design of assembly, and fourth one is mold design. And how mold design is important, that I have explained you in the earlier class, because quality of the product depends upon the quality of mold. And if you are going to manufacture 10,000 or 1 lakh components by using single mold, just imagine how good quality of mold it should be, because this mold is coming across thousands and lakhs of thermal cycles. Thermal cycles means what? Means you are going to inject plastic material into it, hot plastic. It is again because of chilling effect, it gets cooled. So heating, cooling, these concepts are called as thermal cycles. So many times that mold get heated, again it gets cooled. So this happens thousands and lakhs of times. Because of it, the properties may deteriorate. So you should manufacture the mold in such a way that the properties will not be deteriorate for a long time, and it will withstand the number of thermal cycles. So to increase the life of mold, inside the mold, whatever, where the plastic is coming in contact, this area, it is coated with number of coatings, which will give good finish as well as lubrication to the component. And that's why you see that many plastic components, almost all plastic components, in one stroke, if you take it out, you will find it is having good surface finish. So now I want to say that after studying these 4 important parts of the basic parts of the part design, let us see number of aspects to be considered in the part design. Which are these aspects? First aspect is tolerance. Just one by one we will write. First one is tolerance. Second is allowances. We can write aspects of part design. Different aspects of part design. I hope you are noting it down. First one, tolerances. Second one is allowances. Tolerances, allowances. Then design of RIB. R-I-B. Design of RIB. Then wall thickness. This is the important. Then after rib design, wall thickness, then design of corners, design of undercuts, design of corners, design of undercuts, design of holes, then inserts, design of holes, then inserts. I hope you are noting it down. So these are different aspects of part design. You must know how the tolerances are to be considered. You must know what are the different allowances which are considered in the part design. Then next one, see already you know this concept allowances. You have studied in manufacturing process. In manufacturing process, second year, different allowances were studied. It is one type of molding. Plastic molding means molten plastic is sent and then you are going to open and take it as a part after ejector pin. Same concept in casting process, molten metal was poured, alloys or metal. And then as there was a concept of allowances, same concept of allowances is also here as you are going to produce the part by plasticizing or melting the plastic. So this aspect will be covered in the allowances. Then rib design. Rib means what? What is the requirement of, what is need of rib, how it is designed, and what are the aspects of it. Then I was saying this is one of the important concept, wall thickness. Always remember, it is always preferable to have thin plastic component because thick components are difficult to solidify. Metal and plastic solidification. This is interview question, friends. You can note it down somewhere. What is the basic difference in solidification of metal alloy or plastic? I repeat once again. This is interview question. What is basic difference between solidification aspect of metal alloy or plastic? Who will tell? And just I'll take the names now. Akshay Sathe, roll number 53. Akshay, please unmute yourself. Yes. Akshay, your voice is not audible, Akshay.
Hello, sir. Am I audible?
Yes. Now you are audible. Please tell me what you think about solidification of thick plastic part and thick metal part. Where rate of solidification will be more? Tell. Simple question. Where will be faster rate of solidification? Thick plastic part and thick metallic part. Tell.
No, sir, no.
Not audible, Akshay.
Hello, sir.
Akshay, you are not audible.
Hello.
Shivtej Narule is there. Shivtej Narule. Roll number 80. Shivtej Narule.
Hello.
Who is talking? Hello. Ajinkya Jadhav, roll number 23.
Yes, sir.
You just tell your concept. Thick plastic part and thick metallic part. Where will be faster rate of solidification?
Thick plastic part.
Justify.
Because bonding of is less as compared to metallic part.
Where is question of bonding in solidification? Heat extraction. You should talk in that way.
Okay, sir.
Think your thought process should be in that direction. Heat transfer concept is there. Are you getting my point?
Yes, sir.
The answer is wrong. I will tell that answer is metallic part will solidify faster than plastic thick part. I will justify this now to everybody. Unmute yourself now, Ajinkya. So metallic part, thick metallic part may solidify faster than thick plastic part because it is a simple heat transfer concept. It is a good conductor of heat. Metallic parts are good conductor of heat. Plastic parts are not good conductor of heat. That's why if thickness of the plastic part is more, from outer side you may feel that it is solidified, but inner part, core part will not solidify fast, and there is a difficulty in extraction of heat from the outer wall of the plastic for the inner temperature of the core part of the plastic. I hope you are getting my point. If this is the thickness of plastic component, and suppose this part is inner part and this part is outer part, so outer part becomes solidified. This is in contact with mold, but this is inside that plastic part, so surrounded by thick coating of plastic, and here this will be in plasticized state for long time, and it is very difficult for extraction of heat from inner part by the mold wall. It is very difficult for extraction of heat of inner part by the mold wall, because plastic is bad conductor, or polymers are bad conductor of heat. That's why thicker parts of the plastic are 99% avoided. So wherever there is no option, some design is changed. So plastic molding is always preferable for thin walls. Remember this point. That's why wall thickness is important point. We'll see how the design is modified during that part. Design of corners. Now here also same thing. Corner causes larger thickness, and specially design is required for the corners. What are that aspects we'll see at that time. Undercuts means there is different concept of undercut. So in case of welding, the undercut is different. In case of your pattern, the undercuts are different. So here undercut means that area which is difficult to remove outside, and now some extended parts are there, and plastic is flexible. So metal you can't bend and take it out, but plastic you can bend and take it out. That is the beauty of plastic part. Remember. That's why what concepts are considered, that I will explain in design of undercuts. Holes. So if any part is with hole, what kind of design you have to provide? What is the requirement? What should be the position of hole from the end wall? What should be the distance between two holes? All these concepts are covered here. And insert means metallic part inserted in the plastic. So what is the concept and what is the requirement in case of insert? All these aspects are covered. So today we are going to concentrate on tolerances. Now friends, tolerances, dimensions of this product are very difficult to obtain in the closed tolerance because of different parameters. It is very difficult to obtain closed tolerance. I repeat once again, it is very difficult to obtain the closed tolerance because there are a number of parameters. First one is shrinkage of material. First is shrinkage of material. So you are going to provide different tolerances by considering the aspect. In that first aspect was material shrinkage and process parameter variation. Second is variation in what is meaning of this variation in process parameters? Some material require different pouring temperature or injection temperature. Some material require different injection temperature. Some material require different temperature for cooling. Some material may require different holding time. So these are the process parameters. That's why tolerances are provided by considering the aspect. First aspect is shrinkage of material. Second aspect is variation of process parameter. And third aspect is the feeding system. Feeding means getting system. Position of getting system and cooling channels. Position and fourth one is cooling system channels. Channels means the ways, grooves which are made in the mold. Concentrate on this carefully. Very important. So parameters to be considered. Every plastic component have different tolerances because see 1, 2, 3, 4. Because first one is shrinkage of every material is different. Every material shrinks differently. Then process parameters may be different for different component. Feeding system position means from where you are going to inject the plastic, how it goes in the common way, that is runner, and how we insert it, because at a time you can manufacture 10 or 20 components or 4 components. So then gates and runners are required. Then cooling system means if you have some mold, suppose this is a mold, so inside this mold channels are provided by machining. Grooves are provided by machining, and from one end water will circulate inside and it will go out. So if it is injection molding, there is no contact of water with the product. But if it is extrusion molding, cooling is outside the mold. So then there is direct contact of water or air. So accordingly, which type of cooling system is provided, accordingly, tolerances provided on the product are varying. I'm not talking about allowances. Friends, you are in final year, final semester. Try to understand. Tolerances means suppose 10.1 plus 0.1 minus 0.1. 10 plus 0.1 minus 0.1. What is meaning of 10 plus 0.1 minus 0.1? Your product 10.1 dimension is accepted, and for your product 9.9 dimension is also accepted. I repeat once again, 10.5 plus 0.05 minus 0.05. So 10.45 is also accepted and 10.55 is also accepted. The range is given for the dimension. So tolerance is nothing but range of dimension. I repeat once again, this is interview question. I repeat once again, this is interview question. In general, when you are going to attend any core company interviews, it will be asked, what is your idea about tolerance? The limit, fits and tolerance, this chapter was there in the MQC, Metrology and Quality Control, in third year. So you should know what is clearance speed, what is interference speed, what is transition speed, what are different allowances provided, and then how allowances are written and why allowances are required. Because you know the concept interchangeability in design engineering. Interchangeability means what? At national level or at global level, the products are accepted. So this nut manufactured in the south area, 1 lakh nuts are manufactured, and bolts are manufactured in the north area, 1 lakh bolts are manufactured. Depends. Just I am giving simple example for understanding. So any assembly which you are going to make, if fixed tolerances are provided, you can join any two A and P parts, A part with B part or A part with C part. So tolerances are nothing but variation in the dimension provided, and for variation in the dimension provided, different aspects are there which are shrinkage, process parameter, feeding system and cooling system. Now, if See what kind of rules or policies are made by the designers. So if for single cavity, see there are single cavity mold, two cavity mold and multi cavity mold. Means at a time 4 components are manufactured, then it is multi cavity mold. So what may be considered depends upon the property of plastic. In case of single cavity, if allowance is X mm, then for every additional tolerance will be increased by 5%. I repeat once again, what statement is given in case of design? If X is the tolerance for single cavity, if X is the tolerance for single cavity, then for additional every mold, 5% tolerance is increased. 5% means 5 out of 100. So for example, so I hope you have written this. I hope you have written this. Now write one statement. Write one statement. In case of single cavity, if allowance is X mm, then for every additional cavity, 5% tolerance is increased. Example, for single cavity, cavity means mold cavity. Allowance is equal to plus minus 1 mm. Allowance is equal to plus minus 1 mm. Then for 10 cavities, is for each cavity 5% more. 5% means 0.05. 0.05 into 10 becomes 0.5. Allowance is equal to plus minus 1.5 mm. How it comes? 0.05 into 10 is equal to 0.5. Five percent means 0.05. Okay. And make star mark and write. Make star mark and write. Dimensions of molding parts. Dimensions of molding parts are directly related to dimensions of cavity and core. Dimensions of molding part are directly related to dimensions of cavity and core. So, factors related with the working dimensions. Factor related to working dimensions. Factors related to working dimensions. First, shrinkage. Shrinkage. Shrinkage is natural behavior. Shrinkage is natural behavior. And hence, dimensions will be provided accordingly. Additional dimensions. Means if you want 10 mm, then shrinkage it may cause 9.8 mm. So increase size of cavity, make cavity size 10.2. So after shrinkage it will become 10 mm. This we have studied in manufacturing process. Same concept. Okay. Then manufacturing tolerance. Second is manufacturing tolerance. Second, manufacturing tolerance. manufacturing tolerance means what? It is whenever you are going to manufacture different components, so they are directly influencing the dimensions. Usually 1/3 to 1/6 of the tolerance are considered. Okay, and there is concept of RA value also, roughness value. So accordingly, you will provide some extra dimension to the cavity. Abrasive loss. During use. Abrasive loss during use means suppose this is 10 mm and I am using it. Every time I am rubbing it, it may become 9.2 mm after use, after rubbing. But it will not affect much because it is pen. But if it is fitted somewhere and 10 mm part becomes 9.8, then it may cause misalignment. Or it may cause whatever the structure may collapse. That's why that consideration will also be there in case of abrasive loss during the use. So now let us see the illustration. How to modify the tolerances. How to modify the tolerances for easy access and easy selection. Modification of tolerances. Modification of tolerances. So, initial and modified to. So, modification of tolerances are required for exact precision and accuracy. So, you can write precision here instead of writing accuracy. Modification of tolerances are required for precise dimensions. Modification of tolerances are required for precise dimensions. Initial dimension modified to, it will cause easy molding and easy obtaining the precise components. 10 plus 0.2 plus 0.4. So there is one component. There is one component whose dimensions I require 10 plus 0.2 plus 0.4. Means my size variation from 10.2 to 10.4. Okay, if anybody will manufacture 10.25, okay. But when you are putting it in the standard of the tolerances, it is not fitting well. Why? Because people are considering 10 as a base. People are considering 10 as a base. But I want to take it to more precise side. Listen to me carefully. In this case, people are considering 10 as a base and then they will play between 0.2 to 0.4. But I want more precise. How I am writing? Check. How it is looking now. So you have increased requirement. What? My dimension should be 10.3 minus 0.1 and plus 0.1. So here you ensure that your minimum dimension will never go beyond 10.2. Try to understand writing style in the tolerances. If you write in this way, laborers will definitely make mistake. And it is very difficult for measuring it. But here, it is easy to measure. Are you getting my point? So 10 plus 2.4, that is modified to 10.3 minus 0.12 plus 0.1. This is the writing dimension style. Then mold dimensions will be these are the part dimensions. Accordingly, mold dimensions will be different. Okay. So now you take one more example. minus 0.4 minus 0.2. 10 minus 0.4 to minus 0.2. Minus 0.2 is more than minus 0.4. That's why it is at upper side. Now, how can we modify it? It will be modified to 9.7 minus 0.1 plus 0.1. See here now. 10 minus 0.4 means 9.6. 10 minus 0.2 means 9.8. So your part should play between 9.6 to 9.8. But you are writing it with base 10. So people may confuse here. That's why writing style should be modified to and applied style, not only writing style. It is applicable. So minimum 9.7 is my requirement. 9.7 it must be. If it is 9.6, okay, I will accept. If it is 9.8, okay, I will accept. So minimum requirement is that 9.7. You must make the dimension with 9.7. And plus 0.1 minus 0.1 is accepted. So that's why the important principle of modification of tolerance is explained here. Now we will write one chart about total tolerances. So one side is manufacturing tolerance, other is operating tolerance. I hope you have noted down this. Please, I will take one more minute, write down this. I hope you have noted it down. Total tolerance. Now, total tolerance is divided into manufacturing tolerance and operating tolerance. Manufacturing tolerance and operative tolerance. So this is manufacturing tolerance. Again, you can write mold and process. Mold related, process related. Mold related and process related. Now, mold related. Mold related tolerance are manufacturing and wear. Here we write deviation, shrinkage calculation, deviation from shrinkage calculation, and then mold tolerance, which includes manufacturing and wear. Manufacturing and wear. And operation tolerance are different. Post shrinkage, swelling, change in temperature, and change in moisture. Here I will write in this way. Operating tolerance means during operation. Post shrinkage tolerance is after solidification, means the part will change its size. So that tolerance should also be noted. Swelling. So there may be sometimes swelling. Change in temperature tolerance. So working temperature may be different. Then in that case, tolerances are affected. And moisture condition. Change in moisture. You can take screenshot and you can note it down in the notebook. Just wait now. I'm taking the attendance. So friends, in today's class, what we have covered, we have seen the next important part in the part design, that is tolerance. Tolerances are affecting on the overall dimensions of the component. So different parameters to be considered are shrinkage of the material, then process parameters, then position of the getting system, then cooling channels or location of the cooling channels and system provided, Shrinkage is the behavior of material. Different process parameters may also affect the tolerances of the component. Then how to modify the tolerances? So part tolerances and mold tolerances both may be modified by considering taking closest dimension to avoid the confusion of the manufacturer. And then in general, this chart of tolerances is kept in front of you. Manufacturing tolerance, operating tolerance, in operating tolerance, post shrinkage, swelling, then change in temperature and change in moisture may also affect the sizes. And then in manufacturing tolerance, mold and process related. So mold related are again shrinkage and manufacturing and wear. Wear means rubbing. I have explained it in previous 5-10 minutes before. So when you are using the part abrasion, if any part is used in an assembly and then because of more use, there may be removal of the upper surface and then it may cause problem during the working. So all these concepts, to avoid it, if I want 10 mm exactly, I will make it 10.2. So by using it 2 years, that 0.2 mm may get weird. Let it be. My 10 mm may remain fixed. So accordingly, tolerances are provided. Short note may be asked for 3 or 4 marks on the tolerances. Then chances of asking MCQs also. So I repeat always, there are many chances on asking the questions on this bit, chapter number 4, for your orals and interviews. That's why please keep yourself alert while listening in the online classes. Just wait. So then 1 minute.